Grade 9, so today we'll talk about 1h and 1I, factor and difference of squares and perfect squares. So difference of squares looks like x plus 2 times x minus 2. The difference is only the operations, right? If you expand that, again, you should remember that it's x squared and negative 4. The middle cancels out. So, which is nice, right? Okay, and then we also remember perfect squares, which is x plus 2 to the power of 2. So this is where the square the left, square the right, and double the middle. Okay. So the process that I just did, this was called expansion or expanding. Okay, this is called expanding. So the reverse of it, which means the other way, so if I were to give you x squared plus 4x plus 4, and I ask you guys to factor it, I wanted you guys to simplify it so that it looks nicer, like x plus 2 to the power of 2. That looks more elegant, right? Again, this is the same thing with the difference of squares. X squared minus 4. To do the reverse of it, the reverse of expanding, it is called factoring. So that's what we're going to learn today, how to do the reverse of it. We're not expanding things, we're going to make it compact, little, so you can put it in your pocket. Alright, so let's go to example 1 here. It says difference of two squares, fully factorize 2x squared minus 8. Fully factorized mean, again, to make it simple and elegant, instead of the expanded form, which is like long and hard to read and whatnot. Alright, so the first thing that you want to do is probably pull out the highest common factor, or the GCF, greatest common factor. In this case, it is 2. So you're left with x squared minus 4. So wait a minute, we've seen that before. X squared minus 4 is actually x plus 2 times x minus 2. So that is our difference of squares, right? So this is your fully factorized form. So let's do that again with another one. I want you guys to try this out. So again, find if there's a GCF. 48 divided by 3, it is 16. So pull out. I don't like the negative there, so I'm going to pull it out with the GCF. So I'm going to pull out negative 3. That leaves me with x squared, and then this positive 48, we're going to divide that by negative 3, that is negative 16. Okay. Alright, again, x squared minus 16. I see an x squared. X squared is a perfect square. Also, 16 is a perfect square. So in my mind, this is what's happening here. What I'm doing is to leave the negative 3 alone, like, okay, you're good. But the x squared, I'm going to take a square root of that. The negative, again, it stays inside. And then, I'm going to take a square root of 16. They're both perfect squares, so that means, and this is difference of squares, and what gives it away, you guys, is the subtraction in the middle. That means we have a positive and we have a negative, which is difference of squares, right? Square root of 16 is 4, and voila, we're done. Okay, not too complicated. So, in other words, to factorize the difference of squares, you have to recognize that the first term, a squared minus b b squared, or first term squared minus second term squared, is equal to the square root of the first term, which is a, plus minus, again, the big giveaway is that subtraction there, plus minus, and then we have our square root of the second term. There you go. So this is what you should hold on to. Okay. Sometimes it's not as easy for you to just like, that is a difference of two squares. But as long as you do what I just did there, it'll be okay. Okay. So how about perfect squares? I don't know why, but this is my favorite because I just keep chanting square the left, square the right, double the middle, right? So here's another thing. I always look at the first term and the last term. So I know square root of x squared. X squared is a perfect square there, so it's going to be x. And 25 is a perfect square, that's 5. So we're left with the middle. Double the middle. So is it 2, which is double, the middle, which means 5 times x? Which is, yes, that is 10x, right? So if we put it all together, it is x plus 5 squared. Square the left, x squared. Square the right, 25. Double the middle, 2 times 5 times x, 10x. There you go. Fun, right? Like, it's just so fun in your head. So I want you guys to do that one for perfect squares. You know it is a perfect square, but try that out. So again, the process in your head, it should be checking out the first and the last here. This is a perfect square. The square root is x. Square root of 49 is 7. And let's see, is it double the middle? 2 times x times 7. Is it double the middle? It's 14x. It is positive, but it is not negative. So let's try this out then. Could it be that it is x and then 7? Could it be negative in the middle? Let's try it out. Square the left, square the right. Negative 7 times negative 7, that's 49. Double the middle, so that is 2 times x times negative 7. So that means that's x squared minus 14x plus 49. And yes, that's correct. So this is my answer right here. Voila. And of course, here are the generic form of it. We know the expansion of a perfect squares and the factorization of it. So again, guys, my biggest tip for you is to look at the first and the last. And last but not least, check out the middle, right? So if the middle is a positive, that means it's going to be an addition. If it's negative, it's going to be a subtraction. Easy. Okay, last examples. Alright, for this one, it's not as obvious. So what do we do? I want you guys to try that out. Okay, again, it goes the same thing, same way. Look at first and the last. Okay, square root of 9x squared, that is 3x. Square root of 1 is 1. So, ding ding ding, right? We know it's going to be a perfect square. So, look at the middle now. We just know like double 3x times 1. That's not positive, so it is going to be 3x minus 1 squared. That is our answer. You can check it out again. Square the left, 9x squared. Square the right, positive 1. Double the middle is negative 6x. There you go. Alright, last one. You guys should be able to do this one now. Okay, so you might be like, okay, Miss Steph, you just gave me a difficult one. Because if you look at this, that's not a perfect square. That one's neither. So what do we do? Again, the first thing that you should do though, it should be highest common factor. If you don't see the perfect squares, see if you can pull out a highest common factor. So in this case, let's pull out negative 4. Negative 2. That leaves us with 4x squared minus 12x minus 9. And I just get happy because this is perfect squares right here. Square root of 4x squared, that is 2x. Square root of 9, that is 3. Oh, this should be positive, that's why. Because 9 times negative 2 is negative 18. So let's check out the middle. And we just know that it should be a negative, right? Negative 2, 2x, 3. This should be minus. So this is squared. Okay, and I want to check it before I am too confident. Square the left, that is 4x squared. Square the right, that is positive 9. Double the middle, 2x times 3 times negative 3 is negative 6. X times 2 is negative 12x. And multiply by negative 2. Okay, we're good. And that's it. We're gonna do some practices today, but this should be easy. See you guys in class.